Hey team, it's Mr. Z, and today we're going to look at asymptotes, aka the spot where math breaks. Let's take a look. So basically, there's vertical and horizontal asymptotes. The first one, the horizontal asymptote, I hope you can see that these lines are approaching zero, but never quite touch it. So I want you to know that there's an implication that this arrow, it's going to be closer and closer to zero, but it's never actually going to touch it. Likewise, on the left, it's important to remember that. So it's going to try to approach zero. It's going to get really close. It's going to be 0.00001, or a negative in this case, but not quite zero. Now, there is also a horizontal asymptote. You can see at the y-axis, both of these approach, and the same thing. It is approaching negative infinity. It is going all the way down, but it will never ever actually reach a point on it. That point will not happen. Now, how do we describe it? Well, y is equal to 0 and x is equal to 0. The way I like to remember it is that looking at it, if you have a horizontal line, I can have it here and I can have it here. Typically, asymptotes are represented by dashed lines, but essentially you can look at a point here. This graph is going to be, let's say that it's at 1, 1. Here, let's say it's at negative 1, 1. Do you notice how in both of these instances, the y is the same? If I looked at the point underneath, let's say that this is at negative 1, but negative 1, over here, it would be 1, negative 1, positive 1, negative 1. Notice the y's are the same. Likewise, if you look at a simple graph, look at vertical lines and the behavior. Here are these straight lines. Let's look at a couple points. Notice how this guy is negative 1, 1, 1, 1. This guy would be negative 1, negative 1, and 1, negative 1. Notice in this instance, the x's are the same. This is going to be the biggest problem in remembering, hey, y equals 0. This is going to be the horizontal asymptote. While when it's x equals 0 is a vertical asymptote. And yes, it's kind of like opposite. Usually you think x left to right because of the way we graph. Also, you can think of it as when x is equal to negative 1. On a graph at negative 1, all of the points are fixed at negative 1. Here, negative 1, 1, negative 1, 2. Here, negative 1, 3. Here, negative 1, 4. Do you see how all of those points have a fixed x? The y can change. This is the same for when y is equal to negative 1. Well, negative 1. All of these points will have a x value of, or a y value of negative 1. Okay, let's go on to the next example. So looking at it, dashed lines represent asymptotes. I see a dashed line already provided for me. I do want to stress that this graph is going to get super, super close. It is never going to ever touch it. That's what these arrows are representing. It will never, ever, ever cross that line. It'll get close, but never touch it. So where is that line at? Well, the line is at 3. What is fixed at 3? Well, the y's are all fixed. I can do the same thing for my asymptote. There's a horizontal one at x equals 0. Sometimes you might see me use HA and VA as abbreviations. This has been an introduction to asymptotes. We're going to continue to dive deep.